Welcome to EECO Ask Why, a podcast that dives into industrial manufacturing topics and spotlights the heroes that keep America running. I'm your host, Chris Granger, and on this podcast, we do not cover the latest features and benefits on products that come to market. Instead, we focus on advice and insight from the top minds of industry because people and ideas will be how America remains number one in manufacturing in the world. Welcome to EECO Ask Why. I'm your host, Chris Granger. I'm looking forward to spending some time with you today. And we're going to continue our look into industrial control panels. We've had that focus over the last couple episodes of EECO Ask Why. And today we're going to dive a little bit deeper into connectivity and data acquisition. Okay? And because these control panels, they're evolving. And if you've been around industrial automation for long enough, you've watched the goalposts kind of move, right? Control panels used to be judged and primarily on whether they were safe, if the wiring was clean, and if they were capable of running the process that was defined. And that's still the baseline, okay? But it's no longer the finish line. Modern manufacturing demands real-time awareness. That's it. We need to know what's running, what's drifting, what's getting ready to fail, and what's the process doing right now in the moment. And then we need to be able to look back. What did the process do over the last shift? And those questions can't be answered consistently without two capabilities built into the control system. And that's connectivity, so how the devices communicate with each other, and data acquisition, how the system captures and interprets those signals. So at EECO, we're all about helping customers design and modernize control panels that don't just control, but they connect, they inform, and they enable to better decision making. See, that's what it's all about. And they belong together. Connectivity and data acquisition belong together because without, connectivity without meaningful data, that's just a network, right? So, and data without connectivity is just trapped inside the panel. But when the right data is captured and moved reliably, you get outcomes that really the industrial manufacturers care about. You can troubleshoot faster. You have less downtime. You can have early warnings of abnormal behaviors and conditions. You can have better process stability and quality. You have clearer visibility for maintenance and operations. And then ultimately, you're working towards a path of better OEE improvement, right? And that ties in directly with predictive maintenance. And that's the difference between a panel that simply runs a machine versus a panel that becomes part of the whole smarter integrated plant, right? So at the backbone, at the heart of all this, though, for the industrial control panel is the network. And most facilities now expect the industrial devices to communicate. And they're communicating primarily over Ethernet. There are other protocols, but Ethernet is the primary one. So we're talking about your PLCs, your HMIs, your drives, your smart motor protectors, all the stuff we talked about, remote IO, vision system, everything. It's all connected. And this happens through a couple means. You have switches and routers. And they each have a specific purpose. And at EECO Ask Why, we want to help you just get a baseline of understanding of what those are. So you can think of that switch as the traffic director inside the plant. Because that switch is the device that connects multiple Ethernet devices together on the same local network. So think inside the plant or inside a cell of the manufacturing. So if a PLC needs to talk to an HMI, a drive, and an IO rack, they are plugged into the switch. And that's an easy way to think about it because the switch creates that local communication, like a neighborhood, and devices in that neighborhood can share that data quickly and reliably. And switches manage who talks to whom so that we don't have that collision of data, right? That's very important thing to consider. And industrial switches are designed for environments where office-grade equipment just quite honestly just can't hold up. Because in industrial manufacturing, think about it, you got a lot of noise, you have vibration, you have temperature, you have continuous duty. These things are running 24/7. And so many of these things are important when you're selecting the industrial switch. You don't want to go to Home Depot or rather Office Depot rather than just pick one up. right? And if you do the right stuff, like you can start managing switching, you can even have traffic prioritization, monitoring, diagnostics. You can set up your VLANs with that, and so you can segment. That segmentation is so important as well. And then you can start building in some redundancy protocols, right? So practical example is a PLC can request a drive status, read a meter, and update an HMI screen every second through a switch, right? That's not nice to have stuff anymore. That's a have to. We have to have that. And that's why these modern systems and panels are so responsive, diagnosable, and scalable. And then you have the routers, okay? And the routers is kind of like the gateway between the networks. And a router is different. It connects one network to another. So if the switch is the neighborhood, the router is the highway interchange. In industrial control panels, routers are very, very commonly used to collect machines or cells to the plant-wide network. And they can also securely separate an OT from an IT, right? And the router gives controlled access for remote monitoring or support. So routers can enforce rules about what traffic is allowed to pass between the networks. And that matters because it's not just about connectivity, but it's so much about safe, reliable connectivity, right? So if you have your PLC and your HMI communicating on a local machine network, the router can provide a control pathway to send whatever data set you want to a SCADA system, to a historian, or higher level monitoring platform without exposing the control network necessarily. So you see how that works? That's just a big deal. And then you can take this even further. We've talked routers and switches. Now you can go beyond the plant using USB, like cellular modems for remote monitoring. So connectivity gets even more valuable when it can be reached outside the plant, especially if you have remote sites or critical processes or operations where they need that immediate response. And you can do this through a router and a cellular modem, right? And they give you that internet connection that you're looking for, similar to how like your cell phone connects to a network. And then the router uses that connection to transmit selected information outwards. And this is really cool technology because then you have alarm notifications. You can build these remote dashboards. You can have remote troubleshooting, and you can get support for these assets, while you're not there. So if a process trips at 2 a.m., because they never trip at 2 p.m., right, when everybody's there, but 2 a.m. it's going to mess up. When that happens, minutes matter. And if you have this properly configured cellular connection, the right team can receive the right alerts immediately, see the status before the issue turns into downtime or production loss, right? And this is really so useful when the assets that you're working on remote, or if you have a lean staff, or if you have critical alarms that you need to know about quickly, and you need that visibility. This is a great way. And at EECO, we can help you think through the practical side, right? Well, which data is transmitting, what alarms are important, and how can we keep it simple and secure, right? And then once you move in all that data, it comes down to the point of data acquisition, because you got to turn those signals into decisions. And so networking moves that information, but the IO captures it, right? In industrial control panels, data acquisition often centers around, your different types of inputs and outputs, because the real world is rarely just on and off. It's usually in a range. So you have to think analog, right? So you have these analog inputs, and they're reading these different varying signals. And analog inputs typically they come from instruments that put output signals, like a 4 to 20 milliamp. You'll hear that. That's a common one. Or 0 to 10 volts. Right, that's a common one. So just if you hear those types of nomenclature out there, that's typically what we're talking about. We're talking about an analog input or output, right? So if a digital input tells you the tank is full, an analog input will tell you, well, it's 50% full or 78% full, right? It's going to tell you how it's changing in a very specific format, right? And that tank level is just a great kind of example for you, because that you have that level transmitter that's getting that continuous signal on the height of the volume or whatever's in the tank, the PLC is reading that value to control how much is being allowed into the tank or emptying out of the tank. And then you can create alarms like high alarm, low alarms, and critical threshold alarms as well. And then you can start trending that data, right, to spot abnormal behavior. So maybe if your tank gets a leak, right, or a valve gets stuck, right, you can see that. Now from pressure, like if you think about a pressure transmitter, and that sends a varying signal based on that line pressure specific, the PLC can use this signal to regulate, to protect equipment and maintain stability. All the stuff's out there, and the pressure trends can reveal, if you have something that's clogged up or if you have a pump that's failing. See how you can use these analog signals to better understand that. Then you have analog outputs to control things smoothly, not just switching stuff on and off. So analog outputs can send a continuous control signal to things like control valves, right, like position control, or variable frequency drives, VFDs. We talked about that a lot in EECO SY in the past for like speed reference. That's a common thing you can do with your analog output, or pump control just to rate the flow of the pump. So instead of just turning a pump on or off, an analog output can help you dial it in, right? Dial in that process. And lots of times you can do that and save some wear and tear. And when you're controlling, and when you think about this and you start combining analog measurement with connectivity, man, then you get a control system that can do more than just reacting. It can start stabilizing and alerting and improving. And this is, when you start thinking about from a practical standpoint, think about a tank that slowly is rising beyond its normal trend. The system's going to flag it. It's going to flag that field behavior, right? Or that pressure profile starts to shift over time. Maintenance is going to be able to see that and be able to go try to diagnose the signs of, okay, what's causing the restriction, right? Or like the cell modem transmitting the alarm immediately, and then the response time goes down dramatically. Because this is what it's all about: data acquisition, and be able to continually have that visibility into the system so that you can act sooner and smarter. And that's what we're trying to do. This is what, at the core of Electrical Equipment Company, this is what we try to do. We're trying to help you build panels that communicate and inform. And there's plenty of people out there who can sell networking gear or I/O components. The bigger challenge is designing the system correctly so that it's reliable, supportable, and aligned with how your operation actually runs. That's important. So we work with a lot of manufacturers and OEMs and industrial teams to help you select the right switches and routers for the environment and for the traffic, to help you build that clean network architecture that supports growth and diagnostics rather. We really are big on helping implement remote connectivity solutions and considering the cellular solutions out there as well, but thoughtfully considering those, not just throwing at everything. We want to be very thoughtful and intentional about where we go with that. And then trying to specify and apply analog I/O correctly to help you think through a stable control and usable data. So this is all about a goal towards modernization and helping your plants grow. So whether you're building new panels or upgrading a legacy system, the goal is the same. You got to connect to what matters. You got to capture what matters, and you got to make that information usable. And that's what we're trying to do at Electrical Equipment Company each and every day. That's what we do rather. We help our end users do this on a consistent basis. So if you're evaluating a modernization initiative, or you just want to kind of have a better understanding of what good looks like in the network and data acquisition world, particularly inside of a control panel, this is what we do. We're here to help. We would love to help you think through what those next steps would look like. So hopefully you enjoyed this and maybe learned a little bit more about industrial control panels and data connectivity and modernization and data acquisition. So this is important stuff, we feel like, at Electrical Equipment Company. Again, we have all our resources can be found at EECO Online. If you don't have your EECO Online account set up yet, please just connect with us. There'll be links in the show notes as well for you to be able to do that. That's the easiest way to get connected, to see parts, to see availability, to see pricing, to connect with our team directly. We also have labs set up all throughout our geography. So no matter where you're located, there's going to be an EECO lab close to you. And why does that matter? Because if you want to come in and start working through some test cases or just scenarios, we have the perfect sandbox for you to do that. So again, connect with us. All the links will be set up there, and all that can be found at EECOonline.com. So hopefully you're enjoying these. You're learning about industrial control panels, and along the way, you're just building up your confidence in the industrial automation and industrial manufacturing. So thank you guys so much for hanging out with us. This is the first episode of 2026. We're excited to be back with you for another year. So looking forward to spending some time with you each and every month. Love to hear your feedback and your insights. If you have any questions, just reach out to us. Again, all the connections and all the ways to get synced up with us will be found directly in the show notes here. All right. Well, have a great day. Get after it. And just remember to keep asking why. Thank you for listening to EECO Ask Why. This show is supported ad-free by Electrical Equipment Company. EECO is redefining the expectations of an electrical distributor by placing people and ideas before products. Please subscribe and share with your colleagues and friends. Also, leave comments, feedback, and any new topics that you would like to hear. To learn more or to share your insights, visit EECOSY.com. That's EECOASKSWHY.com.